Alrighty Teddy, folks. I started this up with the wrong thing. Need that one. Helps if you turn it on. Duh. Hey, alright. So, as you guys can see, probably, maybe, bit of specularity because the camera's sitting out in the sun. Shame on you, camera. Anyway, back to the intro, I guess. Alrighty, tidy folks. We're back in the Civic, the Project Civic. I just wanted to do a short little stream and a little bit of record, so we can start that right now. Bam-a-lam. Alright, so I wanted to do a little stream, a little bit of recording, because I'm going to turn this into a video, probably this week. Showing you guys kind of the results of the ECU mods that I did a couple days ago. And you won't be able to see it clearly here in the stream because I'll pull the Logitech down here and give you guys a shot of the Lenovo here in a minute. But I am recording the screen on the Lenovo so that we can cut shots of the tuning program into the end cut. Actually, why don't I do that now? Why don't I do that? I don't do that because that sucks. That's why I don't do that. So let's see if we can just get, like, the relevant data. That's all we really need is that right there. This freaking cord does not want to stay where I tell it to stay. Okay, really? You gonna stay there? Are you gonna stay there? I'd appreciate it if you stayed there. Okay, so we got our handy dandy key aerator here. Stick him in there. Put the mouse back up there. In case I never showed you guys, I don't know that I ever did. Huh. In case I never showed you guys, this is Neptune RTP running on the Demon 2 in the stock Honda ECU. I'd call this sort of a crossover between a piggyback and a standalone. It does piggyback onto an existing system in that it is a chip that's simulating external memory installed inside the ECU. So it's more closely related, I guess, to EEPROM systems, where you have a chip that you slap in, that's got your tune on it. Holy crap. I don't know what the heck that is. Anyway, it is quite closely related to EEPROM, wherein you have a chip that you slap into the ECU, that's got your tune on it. Some ECUs have the ability to program well, I guess most ECUs today. So I'm still living in 2008, where some ECUs have the ability to program on the fly, and some you have to remove the EEPROM and stick it in a burner. That's no longer the case. Most vehicles today that use EEPROM tend to be programmable via the OBD2 port. You just need the correct program to do that. So Oh, so this is sort of similar to that. I can program via Neptune. I can program on the fly. I'm pretty sure that if you change a parameter while the parameter is being accessed by the MCU, the main calculator unit, that it would hold that parameter in a buffer until the request has closed, and then it would rewrite it, verify it, and then move on, etc., etc. I'm gonna start the engine here. I don't know how the audio is gonna turn out. Actually, I'm gonna move the mic closer to me. And my car is like a mess of cables because of the way that I do all of this, the streaming and the recording and the audio and blah 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 blah. All of it. There's an absolute nightmare in here. Look, dingly dangly microphone. Hey, boom guy. You failed. I also gotta make sure the cannon doesn't overheat. Periodically check the outer casing. So what we're gonna do, okay, first thing we're gonna do is we're just gonna turn the key on. Engine cold, hasn't started today. We gotta connect the USB. It's supposed to do it automatically, but 85% of the time it doesn't for whatever reason. It sometimes does, but usually it doesn't. So you can see we've got some numbers here jumping about, and that's just because the ECU is a digital device. It's not an analog device, but you're running analog signals into it. Obviously, they're mostly variable voltage signals, and you have to turn that into something the digital calculator can use to calculate what the inputs are doing to give you a value based on the algorithm of the map, to give you an output to the injectors and the ignition system to control the various bits and bobs correctly. So excuse me. It only seems to be in the morning when I get this, like, gurglies. I don't know. It's really weird. I should probably also send a link to people before we get too far. Because I don't know how long this stream's gonna be, honestly. It might be a short one. It might not. But it runs. It might be ugly, but it runs. But it runs. Copy that. Bum 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 bum. Fish. Oops. Bam lamb. Alright. Now, what the? Canada's trying to focus on the specularity instead of the the autofocus on the Canon EOS M50. I don't know. It's the algorithm is terrible. It's terrible. It half the time it does what smartphones do. It doesn't focus on the region that you tell it to focus on. It focuses on something else. I've tried changing the settings. I've tried changing the parameters. Tried giving it different weighting, and it never quite works the way that I think it should. Of course, it is just a device, and it can only do so much. At the end of the day, it's up to me, the user, the operator, the guy that's supposed to know what the heck he's doing to get the thing set up correctly. So, it's fine. It is what it is, as much as I hate when people say that. It is what it is. So excuse the specularity in the cannon. It is. I could bring out the canopy. Maybe I'll do that. Maybe I'll bring the canopy out so I don't have to worry about it. And I can sit here for a little, because I'm going to be sitting here for a little bit while we warm the engine up. So we're going to disconnect that guy, because if we turn the key off with it connected, Neptune freaks out and just, it throws a code and shuts down and locks up the computer. So we're going to move you out of the way real quick. Make sure the door ain't going to hit you. I'm going to grab the canopy so we can put the cannon in the shade. And then I'm going to, we'll start the engine, and I'm just going to let it warm up naturally. Because I kind of have to relearn the idle anyway. So we can do that. And that requires letting the engine warm up on its own. Which means I'm going to remove the fuse under the hood real quick. The 7.5 amp backup fuse. So that we can clear the memory. I was fiddling with the idle the other day. Yesterday. Yesterday's the other day. That other day. Sometimes this thing's really annoying. I have a sneaking suspicion. Alright. That should be better. I'm gonna turn the music down. Okay. I gotta remove fuse real quick, which I should have done first thing. I also need to start working on the hood. Now that I've got a bunch of the data, what I'm thinking about doing is before I start working on the next version of the hood, see me through here? No, you can't. Okay, well, before I start working on the next version of the hood, maybe what I'll do is I'll do what'd you call that? Airflow test with yarn and tape. Tape a bunch of little short pieces of yarn and a grid pattern all over the outside of the body, and you can test and measure the airflow characteristics around the body. I don't know that I necessarily need to do it. The car is fairly symmetrical, so I probably could get away with just doing like the passenger side. So the driver's side's open and I can see where I'm going, because I definitely want to see the airflow over the windshield. Absolutely, for sure. And then I want to see the airflow over the cowl, see what it's doing. And I especially want to see the airflow at the edges of the hood, the fender, the mirror, and the side doors. I guess the doors, not the side doors. I have not yet started work on my idea to turn this thing into a 5-door hatch. It'd be a sedan wagon is what it would be. But I've had this idea for a while, and I might end up doing it. I don't know. The more I talk to people, the more I think that it's probably something I should do. Because I could reseal the back end better, because I got rear-ended some time ago, the metal in the back's never quite been all that straight, so it's it's kind of annoying having all those gaps in there. Air and moisture and everything can come through it pretty easily. But what I'd have to do is I'd have to remove the headliner and the plastics in the back that I put back on. I guess plastic in the back that I put back on. I only did the driver's side apparently. I'd have to cut the support, the body support, away, leave the skin intact, build a frame inside, which I already sort of have a frame to the strut towers anyway. So build a frame around that, and then put hinges and figure out a way of sealing that whole thing. I'm thinking seal on hatch instead of seal on body like Honda did with the trunk lids on this. I don't remember if the doors... Yeah, the doors have the seals on them, not the body. So do it like that instead of the trunk lid being sealed, lid flange to body seal. Okay, that should be long enough. Alright, so I don't know necessarily that it's needed, but I guess we'll do a quick recap. Close the door, sorry for the sound. There we go. Yeah, I don't know that it's necessarily a requirement, but I guess I'll do a quick recap for anybody that's interested. I modified ECU. I previously had one of my 2 widebands coming into the ECU at what the community has called the B6 input, which in reality is B14 according to Honda. For whatever reason, the community didn't look at the PCB when they started counting pins. They just assigned some random value to some random corner. They called that 1, and then they counted away. The pins are marked on the PCB on these things, so maybe those numbers come from a different PCB model or version. I don't know. But the B6 input, we'll go with the community's convention that they came up with, since anybody that sees this will probably be looking specifically for this type of thing. which means the information they're going to have is going to be based on what the community has provided, especially since Motes.net shut down. Chris Motes and Dave Blundar are no longer doing tuning stuff. They shut the site down, and nobody really knows. That was about a year ago, and nobody really quite knows exactly what's going on with that. So, like, you know, again, I guess it is what it is. So, I had initially the wideband coming into B6. Problem I had with that was after removing the voltage divider that I showed you guys R1, 2, and 3, I did something wrong. I don't remember. I think it was the pulled pads. The pulled pads is probably what the issue was, because I didn't realize that the 3 pads that were right beside each other at the one end of those 3 resistors were all common, and the data line came off of one end that I wasn't actually using. So it was just kind of floating at whatever value the ECU was floating at, which is why it never worked correctly. When I did the mod, I did repair that circuit, I guess. I jumpered the wires so that the data connection was correct. I turned the B6 input into this guy right here, intake air temperature pre-filter. Okay, and that guy is kind of important because it's going to tell me how much the intake air is heating up between the filter and the intake manifold. That'll give me, can give me the amount of thermal energy on being input into the air over different RPM ranges, right? Because it's obviously going to change. If you're at idle, the air has more time to soak in heat before it gets into the cylinder, which is fine for fuel mileage and efficiency, not so fine for power. This being a fuel economy car, I would prefer it to be fuel efficient, so heat is probably better, but I also want to have the passing power to be able to, you know, you're driving down the road, middle of the night, 2-lane highway, it's got a bunch of twists and bends, you come across a truck that's doing a night haul, and he's doing 55 and the road's 65, right? Obviously, most people, even myself, you know, Mr. drives reasonably. I refuse to exceed the speed limit if I can absolutely avoid it. Most especially if there are other people on the road. If there's nobody on the road and it's the middle of the night and it's just like empty land, there's nothing around that you're going to damage other than yourself and your car. At the end of the day, who cares? Seriously. If you're not hurting anybody else, the whole reason laws and everything exist is to prevent people from hurting each other, not themselves. Of course, the federal government would have you believe otherwise. Conspiracy, insert conspiracy here, blah, 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 whatever. Anyway. But if there's other vehicles on the road, I will not exceed the speed limit. I use my turn signal, etc., etc. Not getting into that today. It's a whole other thing. So, if you're on the road, middle of the night, and you're like, oh, you kind of peek out. Oh, I can't pass. The line's changed. And then, oh, the lines are back. Okay, you peek out, and oh, the line has changed, and there's a hill, and it's like, if you have a car that has the ability to pass in that 5 to 10 second window on those windy back roads that I actually genuinely enjoy driving down, I prefer to take state roads as opposed to interstates myself. They're more interesting. The only downside of that is that exact situation. You want to pass somebody and, you know, go on about your business ahead of them because they're going slower than you want, regardless of what the law is and what they're doing and what you're doing and blah, blah, blah. Regardless, you're going faster, they're going slower, you want to pass them. On the little windy roads, that's kind of hard, especially with a lower powered car. This thing, all the time it happens because it's a 100-horse engine, right? There's no power to it. So you pull out, you floor it, you shift down into second, and you're screaming, and then, oh shit, I can't pass now. You gotta slow back down and get behind them, because you don't know what's beyond that curve. At night, it's a little bit easier because you can see headlights around corners, you can see headlights behind hills, stuff like that. But it's funny because most people are more afraid of driving at night because of just the unknown. You know, the monkey brain back there in the back. Don't leave the cave at night because a saber-toothed cat's gonna get you. But I prefer driving at night. A, because there's less people on the road, because many people are afraid of the dark for some reason. B, because it's actually easier to tell what's ahead of you at night with regards to other people. Of course, obviously, the biggest reason that you would not want to drive at night... I need to take my cluster apart again. What the heck is that? Oh, that's the super glue. Ugh. Apparently it wasn't fully cured when I put the case back together. Because it's got some Gerp Gork in it now. Huh, whatever. It's fine. It's fine. I don't care. It's fine. It's fine. I'm going to try to figure out a way to 3D print a better thing later anyway. I don't remember where the heck I was. Is that better? That's better. Okay. There's a little glare there. Sorry. Anyway, low power car, hard to pass at night. I prefer driving at night anyway, personally. It's simpler and less stressful to me. But yeah, so everything I do is in the effort of increasing or maintaining fuel economy while also increasing performance. I haven't really been working on the performance side. I've been doing, I'm gonna call them quality of life mods, adding sensors to the ECU and putting the bigger wheels on. Yeah, it's a little bit harder to stop now until I get some a different brake system on here. But if I hit the pedal hard enough, I can still lock up the wheels, so it's more than sufficient. Disc brakes are kind of, you know, amazing. So I have not really been focusing on the performance and the power aspect, aside from trying to get the tunes sorted, because as we all know, every engine, when you build it, every engine is different, and OEMs have to make the decision, do we want to tune every single engine independently, which will take a lot of time and money and manpower, or do we come up with a tune, we find the best engine, we find the worst engine, we average them, and we put that tune on every car. And that's usually what happens. So if you win the engine lottery, you know, it's kind of silicon lottery for CPUs and GPUs, but if you win the engine lottery, or I guess the vehicle lottery, it depends on a lot of different factors, obviously. But if you win the lottery and you could tune an engine, like case in point, right? Bugatti, when VW builds a W16 engine, okay, the W16 Bugatti engines are built in a clean room. We're talking hard drive data recovery clean room, right? All the people, they wear caps, they wear boots. I'm pretty sure they wear smocks and gloves and masks too. But Bugatti builds the freaking engines in a clean room, and every single one of them comes out with a different amount of power. I saw a documentary, or maybe it was Top Gear. They went in, they were talking to some of the guys. They walked them in through, not the clean room, but I think there's like an observation room adjacent, or there's like an inspection room that, because you're not building the engine, it's already together. You can go in and just have like gloves and a hairnet and maybe a mask or something. You don't have to go full clean dress. But they go in there, and the guy was like, yeah, it's not unusual for us to build these engines. And especially given how far we're pushing these materials, for one engine to have 200 or 300 horsepower difference to the next engine that we build.
That's not unusual. We try to do our best to make sure all of this stuff is exactly what you need it to be. And these guys are going through, they'll have 60 boxes of bearings, or they'll have a bin of bearings essentially, and they're all in trays and they're all separate, and like they check them with mics, and they spec bearings to the block to the crank. That's how precision they get when just assembling the engines, right? And that's part of the reason why they're so expensive, is because each engine takes, 1,000 man hours to put together, or whatever it is. It's insane the amount of care and precision that those engines get. But it's important. It's important work, because the more we do that, the better we get at it, the better we get at manufacturing the parts to the precision, so that you don't need the guy to check every single part. You can have a machine do it, right? The closer and closer we get to automated flying cars, the closer and closer we get to, hey honey, let's go to that amusement park on the east side of the moon there, on the Twilight Ring. What's that? Twilight Splendor, or whatever the hell they call it. Let's go to the moon for the weekend. It's a day trip or whatever. Like, the closer we get to technologies like that, Elon Musk, everyone thinks he's a genius. He's a business genius. He's not like an actual, well, I say actual, genius is genius regardless of how you measure it, right? He's not a scientific genius. He's a business genius. Elon Musk did not come up with the design for Falcon 9 or Falcon Heavy. He had a team of engineers do it. But what makes him the genius is he got those people together in the first place to do that work. That's the genius part. He had the money to buy those people's time to put into that in the first place. That's the genius part, right? Everyone says Donald Trump is a complete dirtbag, or he's a jackass, or whatever you want to say about him. But you know what? He started off with, what, $1 million, $3 million, which, granted, having money in the first place makes it easier to make money. I'm not arguing that. It's not a philosophical discussion. But he turned his million into billions. It takes something special to do that. How many people win the lottery, and then within 2-3 years, it's evaporated, it's gone? Because they didn't handle it right, they didn't handle the taxes right, they didn't handle whatever correctly. The first thing you do, if you win the lottery, is you take that money and you put it into some investment. You put it into real estate, you put it into the stock market, you put it into whatever, you put it into world currencies, something. You do not stick that money in a bank anywhere. You invest it. And then, given that it's such a large sum, and it has been invested, you can then live off of the dividends, or the interest, depending on what you've stuck it in, because you can stick it in, like, I don't know, what do they call those things, CDs? You can stick it in various different things to make you money, and you can live off of that. And you don't need to live, you win the lottery. Huzzah, you're rich now. You don't need to go out and buy a $50 million mansion. What? I have never understood that. The people that are just like, oh, I'm going to buy all this stuff that people have told me is cool now. You know what I want? I want a 4-bed, 2.5 bath house with an underground garage, an above ground shop with, I don't know, we'll call it 15,000, 20,000 square foot shop with, I think, a drive-through style with the kind of winged lifts. You get 2 or 3 bays that are just project cars, and then you get the rest of them you can use to work on stuff actively. And then that would be on around 10 acres of land. The building would be in the dead center, and then there would be, You have your perimeter around your property. You put up a little fence. You put up signs. Trespassers will be violated because A, it's funny, and B, it's a legal disclaimer. Wink, wink. Nudge, nudge. Know what I mean? Know what I mean? Wink, wink. Know what I mean? Know what I mean? Is she a Gawa? Most of you people are too young to get that. Anyway. I feel old when I think about all my like pop culture references, because most of them don't even come from my own time. Many of my pop culture references come from a generation or four but before my own. Call me a weirdo. Call me what you will. I am who I am. I be who I be. We're off topic. We're going to sit here for 4 hours with me making really bad jokes to nobody in particular. That's what's going to happen. I have stuff to do, man. Anyway. I don't even remember where I was at talking about the car. And I got to figure out how to cut all this crap out, make a freaking video about it. Okay. I might leave all that in, just do a time lapse, chipmunk voice. Just be like, rambling. Let's go to the video. Screw it, we're not cutting anything. Okay, so I put the intake temperature sensor on the B6 input. I made a voltage divider that replicates the voltage divider for the OEM intake sensor, so the values into the computer will be the voltage values into the computer via the analog to digital converter will be identical. They're not going to be 100% identical because one goes into one multiplexer, the other goes into the other multiplexer. IC variances, especially in the 80s when these ICs were built in the first place, they'll be close. They'll probably be microvolts close. So not enough that it's going to matter. It might even be millivolts. I don't know what the tolerances are on these ICs. I guess I could look it up. But near enough as doesn't matter. I guess what I need to do eventually, I'll probably do it this week, is I need to get in there and I need to measure with the O-scope the OEM intake temperature sensor and correlate it to temperatures according to Neptune, because Neptune does not give me the ability to view the voltage of that sensor. I can view the voltage of other things. I can view the voltage of the sensor I added on B6. I can view the voltage of the O2 sensor, the stock O2 sensor. I can view the voltage of the MAP sensor. I can view the voltage of the TPMS sensor. I can't see the ECT. I can't see the IAT. I can't see the VSS, which would be a frequency to voltage, which means you could technically see the voltage. As the frequency increases, the voltage increases. As the voltage increases, your speedometer goes up. Right? That's how this guy works. Same thing on any modern car too. They're identical. I only have a single one because I don't have ABS, but newer vehicles, you have a reluctor ring and you have a Hall effect sensor. As the teeth of the reluctor ring pass in front of the sensor, you get a magnetic field that changes a little bit, and you have power and ground, and that creates they have an inductor there, which that is your magnetic field that gets interrupted by the teeth. The middle pin is your data out. So as that gives you spikes, right? And then it goes into a signal conditioning circuit in the input of the ECU, which filters out noise and probably runs through a Schmitt trigger, which gives you then, instead of spikes, it gives you a nice square wave, probably at 5 volts. And then that is a digital signal, effectively. Well, not effectively, that is a digital signal. That's a rudimentary analog to digital converter, effectively, albeit a binary one. But so it does that, sends it to a computer. The computer calculates all the things it needs to calculate, and then does the stuff it needs to do. It's all this stuff on cars is like, it's all the same stuff we've been doing since the 70s. Nothing has changed. And I don't understand, like, everybody's like, oh, well, it's got all these plastic covers, and it's got all these sensors, and that. Dude, all we're doing is we're taking the same thing we've done, and we're just adding a little bit more of that same thing that we've already done to it. It's more, yes, which means it's more expensive, it's more costly, it's more difficult to work on, it's more. But it's all the same stuff. Electrons have a certain set of physics that they obey, just like everything else in our universe. And if you understand that basic set of rules, you can do just about anything. Honestly. Just about anything. So, you know, whatever. B6 input. Solved. I then cut the pin 4 and 5 to RM2, put a little jumper so that the wideband can come in to there. And I can use it for closed loop, which is what I've done. I've modified the program, or I've updated the program, and we're now using the wideband for closed loop. I have yet to do validation as to whether it's better or worse, but I have noticed there's a lot of noise in the signal. The voltage will pretty quickly. So what I need to do is I need to get back in the ECU and put a cap on that line, which is going to be super simple because we have what is that, DM5, that transient protection diode pack, as it were. The middle pin, well, probably not the middle pin. One of the pins is ground, and the other pin comes from that data line. So all I do is I take and I stick a cap on there, which is what Honda did with those signals originally anyway. That's just what you do. I gotta figure out the size of the cap first. That's gonna be dependent on the frequency that I want to be read. I probably want something below the Nyquist, what is that? Nyquist Ryan, damn it. Reinhurst? Nyquist? I gotta look it up. I can't remember the name of that, the second name. Nyquist Shannon? Yeah, there was a name that started with an R. Anyway, you want to be, so the Nyquist frequency is, I don't remember the exact way it goes. I don't remember the theorem off the top of my head. I could have gone down a rabbit hole and looked at it. But the effective outcome states you need your sampling frequency to be at least twice the frequency of the thing you're trying to get data on to be able to get reliable data. And that has to do with sine waves and trigonometry and some calculus and just the way circles work. That's, if you take nothing away from anything I ever say, the way that sine waves, the way that electrons, the way that everything in our universe functions is based on how circles work. If you can make a circle work, if YouTube captions pick this up wrong, I better make sure I'm enunciating. If you can make a circle work, you could do so many things. If you understand circles, if you understand pi, and you understand circles, and you understand square laws, inverse square laws, and quadratic equations. Like, you don't even have to be able to recall them off the top of your head. You only have to understand the concept and their effect on everything, right? Like everything we do, the way that the skin feels, sensation, square law, logarithm, the way that ears hear, square law, logarithm, the way that eyes see light, square law, logarithm. The temperature of stars, I believe, is square law, logarithm. Gravity based on mass and physical dimensions, square law, logarithm. Nothing in our universe is linear. If you look at anything and it is linear, you're looking at too small of a sample. Which we do on our human scale. A lot of times everything is tiny in comparison to the reality. So what we see is a straight line. That's not the case with most things. We were supposed to do a physics discussion and stream this weekend, but I can never come up with a good idea for the background. And I guess I could just record the voice in Discord and then put in a background later. So maybe that's what we'll do. See if I can't get my buddies in a stream this weekend, and I'll stream it. But then I'll also cut down, the most important bits and kind of make a video out of it. Because I got two friends that are either just as interested in physics as I am, or more interested in physics than I am. One of them is a physicist. He has a degree in physics. The other one is an engineer. He's effectively like me, except he went through and got the engineering degree, whereas I'm too lazy and I despise school. So he had more drive to get the degree than I did. We're talking about the Civic. What are we talking about the Civic? Oh yeah, I need to put a cap on the wideband line because it cycles too fast. So it's fine for closed loop because the cycling and the noise frequency is well below the switching frequency, or well above the switching frequency, which ends up meaning that as it swing, or the amplitude, I guess, is what we care about, right? So the amplitude of the noise is well below that of the switching signal. So as it goes rich, voltage goes, actually wideband, as it goes rich, voltage goes down. And it shoots far below the bottommost peak of the noise. So the ECU says, okay, that's my switch low, now I need to switch high, add a little bit more fuel, and it gives you that averaging, which is the short-term and long-term fuel trims. And then, it does that signal. Actually, I tell you what, I can record some of that too. We'll stick that in the video. And the Canon froze. What the heck? Hello? Battery die. No. Battery's not dead. We're still on. We're still going. Why is the Canon not working? Wonder if it's this cable. I mean, I don't necessarily know that it matters. But I would like it to work. Okay. It might be this USB cable. Turn it on. Give it a few seconds. Turn that on. Hey, all right. Yeah, it's the cable hooked up to the Canon. The connection is not very positive. It's kind of weak, and I've been worried about it for a while because micro USB cables suck so bad. Oh my god, they're so terrible. So now that we've got that back and running, I'm going to start the engine. We're going to let it warm up by itself so it can relearn its idle. I've got the idle set. Yesterday, while I was fiddling with it, I got the idle, I swear to God, I got the idle perfect. Perfect. So, we're going to see if that's still the case. We're going to watch it warm up a little bit. So the idle is learned when the fan turns on and then back off again the first time. So, I also want to take eventually and bring the clutch switch into the ECU since there is a pin for it. Easy peasy. Set that up. Not a problem. The VX ECUs, which I believe was the... What are those? PM2s? P2Fs, maybe? I don't know. The VX ECU had the clutch switch installed. Not exactly sure what for. Maybe... Oh, maybe it was the LX's... Yeah, that cable is just screwy. Come on. I don't know. Maybe we don't use the Canon. Tell you what. Turn him off. Unplug. On. The batteries should all be charged. Huh. Well, that one wasn't the cable. That one was the battery dying. And I am like half buried in here. So, you know what? I'm sorry, folks. We ain't... Whoa. What is that? There's schmutz on my lens. It looks like a crack. Better not be a crack. I mean, it's on the, okay. It was a spider web. It's on the UV filter, so it's not a huge deal. But, you know, I'd rather not have to buy another one. So I guess what we'll do is we'll just turn off the Canon. And, we'll live on the Logitech. I'll take the Logitech and turn him around, and we'll just have him looking at me, and then I'll cut in the screen. I'll give you guys see if I can get this situated first. There we go. I'll take the Logitech and I'll point it at the screen here in a little bit, and then that way the stream will get it, but what the video will get will just be the screen record. Okay, well, put this somewhere where it won't get messed up. Kind of like right there-ish. Alright, so now we're going to start the engine, and we're going to see if sitting here idling, it'll relearn its idle and blah blah blah. So when you're relearning the idle, you can't touch the steering wheel because the power steering pump has a pressure sensor, pressure transducer that raises the idle. So you don't, if you're turning the wheel like lock to lock, especially, you don't bog the engine down and it shuts off. The AC is the same way. The ECU is connected to the ECU. The ECU commands the AC relay. No, that's an input. So the ECU reads the AC relay output. And when it's on, the idle raises some amount, which is actually programmable in Neptune, which is good. So anyway, key on, fuel pump prime.
The crank can start, which is good. I'm not sure.
I'm not sure how well the audio's gonna be. I can put the mic closer to my face. Maybe it'll be better. So we can take a look here. Let me get untangled. Take a look here at the widebands. Right. So Honda's factory cold start was like 10.5 to 1. Like, I started it up when I was futzing with the OEM ECU the other day, and I was trying to figure out why the OEM and OEM ECU running the OEM map would not run the engine at all, and I got it working because it was just that voltage divider. So I disconnect the wideband. What I saw was it was running at 0.65, 0.68 lambda, which is like 10.5 to 11 to 1, something like that. And that is crazy rich. I don't think you need it that rich. You do want it a little rich on start, to start the engine, and then once it's idling, you want it a tiny bit rich to help warm the engine up a little bit faster. So what you're getting is fuel, well, you're heating the cat up faster is what you're doing. But fuel's still burning just a little bit as it runs down the first bits of the exhaust tract, heats the cat up faster, gets you into a better emissions mode faster. But also because when the engine's cold, the metal's cold and contracted, things aren't maybe sealed 100% the way they should, the rings are smaller, so the gaps are going to be a little bit bigger. You get the engine runs differently when it's cold than when it's hot. And with my current tune, I will get to stoichiometric, so I will get to about lambda 1 when driving around on the cold engine, because that's how I set it. I set it so that the leanest condition I get on a cold engine while driving around is stoichiometric. So I'm not gonna damage anything. But it's leaner than what Honda had stock. Let me, bam, get you guys like that. So, that. I don't know really where I was going with that, but that. Oh, and I never connected. Crap. It's fine. Engine's still cold. But I didn't capture the crank and start. It's too late now. What I'll do is I'll do another one tomorrow. I'll do another screen capture, and I'll just kind of like glue them together, because the parameters are going to be about the same from cold start up to around 100 degrees ECT. So it's not a big deal. And I don't know if you can hear that, but it started and the engine was fairly loud. But as it warms up, we are now at 970 idle, like dead 970. 960, 950, like that variance is like 10 RPM. Holy crap, that variance is great. So yesterday, I went through the idle control systems, and one of those is the idle ignition control, which is what all modern cars use to control the idle most precisely. You've got so newest vehicles all have drive-by-wire, which I despise. I cannot stand drive-by-wire. I feel it is a completely unsafe system. Newer vehicles are moving into brake-by-wire, which I feel is an unsafe system. Some vehicles have steer-by-wire. There's no physical connection between the steering wheel and the front wheels. I think Tesla's that way. There's no physical connection. So you lose power for whatever reason, you lose electricity, and you're killing people. You're killing yourself. You're hurting children and dogs and birds and squirrels. And it's a really, 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 I don't know how many reallys I can put in front of this to emphasize this point enough. It is not a good system. Your brake system, your steering system, and the systems that control your doors should always have manual redundancies. Every single system should be physically connected to the user in some way. The steering wheel has a shaft, a steel shaft, or an aluminum shaft even, or a Byzantium shaft, or whatever material you want to use. Call it beryllium. Don't call it beryllium, that can kill you. It's similar to lead. It can poison you quite easily. The human body does not like beryllium all that much. Kind of like cadmium and iridium and cobalt. You know, you don't want any substantial amount of these things in your bloodstream. But yeah. So anyway, everything's moving to like drive-by-wire, so you no longer have idle control valves. It's just the throttle blade and the motor. The ECU controls the throttle blade to open it or close it, more or less. The good thing about that, there is actually one good thing about that. As the engine ages, because of emission requirements, you're not supposed to vent oil vapors from the crankcase into the atmosphere, right? You're supposed to contain them or consume them somehow. Most OEMs, what you do is you take the crankcase vapors, you run them into the intake, post-filter, pre-throttle. So it's not in vacuum, so you're not drawing a vacuum on the crankcase. What that upper tube is meant for on the top end of the engine is to draw filtered air into the crankcase, and then the oil, what ends up happening is at higher speed, you end up getting positive pressure in the crankcase, so that tube ends up being oil vapors rising out of the engine into the air box and then getting sucked up into the intake. The same thing happens to the PCV system. You get oil vapors, but generally the PCV is in such a place that the vapors are minimized and you have baffles to prevent that, but you still have tiny little droplets, tiny little bits in there, and that stuff runs through the engine and gets burned up in the combustion chamber as the engine runs, and it's such a small amount that it's not usually an issue. 200,000 miles though of that, and you end up getting oil in your intake tract, which is less than ideal, obviously. So yeah, I definitely need to adjust those. I need to measure the ECU values, because if you look at those guys right now, IAT 64 and IAT pre-filter 70. It should be the other way around. The pre-filter should be colder right now because the engine's warming up, which means the IAT on the intake manifold is going to be warmer than the intake air coming in through the filter. So I definitely need to change that. I'll measure it probably, I don't know, sometime this week. I got some stuff to do tomorrow. I'll be out of town, so I'm not doing that tomorrow. Maybe Thursday, maybe Friday, maybe Saturday, I don't know. We'll do it in stream, so it'll be, anybody that wants to come and join and hang out can do that. But what was I talking about? I was talking about drive-by-wire and electronic systems that really do not need to be electronic systems. That funniness is the Logitech sliding around because it doesn't really have a grippy pad. So, engine's still warming up. We got a minute or two to go. I don't remember where I was going with that conversation exactly. I was talking about automation in cars. Yeah, I don't know. I got distracted by a thing. Alright, so we are not in short term. We're not in closed loop yet, short term. And I am currently running at 151 degrees coolant temperature at lambda 1 stoichiometric, running right dead at stoichiometric 9981001 9981001. 994. No, 998. Oh, 989. Oh, no. We gotta lean that out just a teensy little bit. So, can I do decimals? 0.85. Can I do that? Will you let me do that? No. Won't let me do that. Okay. So we can get it close, but we can't get it exact. Right now we're in the 158 bin, and that is 1. Oh. Oh, well, that's not good. Okay, so we're going to do this. We're going to move all these down 1. Let's make that 15. Okay, and then 67 is 12. 85 is 10. The ECT, I'm stuck in adding 1% of fuel because I'm stuck in I don't know how I did that. Actually, I think I do. I think I did it as an experiment to check something else. So we are running slightly rich. So what I'm going to do is I'm going to move everything down 1 and add another, because when it's cold, wait a minute. $110 is 10. Uh-oh. Might have screwed this up. 125 is 4. 135 is 3. 158 is 1. And then we're going to put a value that is 165, and that'll be 0. Which should bring us back up to stoichiometric. 101, 998, 104. Yeah, there we go. Okay, so what I had was I was missing a value. 158 should have been the trigger to go to 0, but I noticed that it was slightly lean sometimes, driving around like just before it got to operating temperature. So I was like, I'd rather not do that. So what I ended up doing was adding just 1% to that, and so this whole time I've been adding 1% to everything. Wow. Probably 0.85. Once it's fully warmed up, it was between 158 and 250. So along that line of 1 to 0, between those two values, I was somewhere along there. So probably 0.8% fuel I was adding, which is fine. Short-term fuel trim and long-term fuel trim, closed loop, would account for all of that. So it's not a big deal. And I'm still removing 5% in short term right now at idle, not touching anything at 168. Yeah, I definitely need to put a cap in there. Turn you around. Look at that. So that bottom left guy there, 14.6, 14.7, 14.8. That is, it says EGR lift input, which is just what the pin is called. That is that D12, D11, D17. D17 that we converted from the non-existent EGR lift input to the wideband output, which is actually cylinder 1, which runs slightly differently than every other cylinder. What I need is 4 widebands and the CAN bus controller for them, or the AEM net controller, I guess, because what I would really like to do is average all of the wide bands. I guess what I could do, I could replace the narrow band that currently does sit in the collector, just below the collector. It's right underneath the oil pan, actually. Could replace it with a wide band. Problem is I need a controller, because I could bring that straight into the ECU on the O2 sensor line as it is. I wouldn't have to do a whole lot of modification there, because I could just bring it into the connector that already exists down there. I don't know. I keep trying to come up with an idea for using the O2 sensor line, the factory O2 sensor line. I don't know what I want to do with it quite yet. Yeah, so there's that signal's like let's check voltage and real world. Yeah, 333, 327, 321, 318, 316, 314, 327, 333. Yeah, so it's got quite a bit of noise on it. And later, if you guys want to see that, I'll pop the oscope out and I'll look at both of those signals, the ones I added, and the temperatures, the intake temperature sensor OEM. Now it makes more sense. Now it says manifold intake temperature sensor 86, and then ambient temperature sensor, pre-filter temperature sensor 70. So that makes more sense. Oh, I tell you what. Yep, the air box is in the sun. So that makes sense, actually, why it would be warmer a little bit earlier. Because the intake would be cold, and it would warm up slower than the plastic of the intake in the sun, or the air box in the sun, because the air box is black. So it's going to absorb more heat than the intake manifold that's in the shadow. Makes sense. So, we just gotta sit here. Engine coolant temperature is 170. The fan will come on at 192, I believe. 196. So the fan will come on at 196. So we have another 25 degrees to go. But yeah, it idles. It's currently at 820. So it's 815 to 832. So that's within 20 RPM of what I have commanded at 820. And the reason for that, oh yeah, that's what I was talking about, smooth idles. So the reason for that, if you look at actual ignition there, right, and you can see it's kind of jumping around like grasshopper on the asphalt in Texas in summer, you know, one of those guys. The table ignition says 16, which is what the whole region of idle is set to. I can actually show you guys that in the stream right now. So you can see up here, it'll focus. Hey, focus. Why won't you focus? Focus. Thank you. So you can see all of that is 16, 17, 18 as it gets a little bit higher in load. And I found 16 to be kind of the best compromise. 12 degrees at idle gives you... The problem with 12 degrees is coming up off idle is more difficult. It takes longer. And we're talking milliseconds difference, but it's driving it around, especially in the summer, it's noticeable. So the better way to do it is you set, especially with fuel injection and computer-controlled ignition systems, you set the value to something that is good and that works, and then you adjust the idle to maintain idle by adjusting the ignition. As you, let's see, what is it? You advance the ignition, the idle goes up. You retard the ignition, the idle goes down. As you richen the mixture, the idle goes down. As you lean the mixture, the idle goes up. Right? If I remember right, that's how it works. I always remember experimentally is what I do. So set the idle, or set the ignition at idle to be the best value that works without any corrections, and then you turn on idle ignition corrections to maintain the idle, because solenoids like the throttle plate on newer cars or actuator valves on older cars, they're slow. They're big, they're heavy, they're bulky, and they're slow, because in an inductor resists change in current, which means to change the current, you have to change the voltage, because an inductor is effectively a set resistance. But a whole lot of things, math and stuff to go into. We're not going to do that today. But so you ramp up the voltage to ramp up the current to make a change to the solenoid, or you ramp it down to change the current to change the solenoid. But that whole process is slow. It takes hundreds of milliseconds, tens to hundreds of milliseconds for that piece of machinery to start moving. Even though physically it's small, compared to a human, it's a piece of small machinery, it's still slow. It's very, very slow. Which is why making powerful speakers is hard. You have to have a bunch of different speakers to accurately reproduce a sound, because moving a large speaker quickly, you can't get highs out of a 12-inch woofer easily. You can do it. There's ways of doing it, but it ain't easy and it ain't cheap. So the cheaper, more effective method is to have a bunch of different systems. You're not going to do that for an intake control system. You can have one solenoid that controls mass air into the intake to maintain an idle, and then you just adjust the ignition, because that is very, very quick. That happens every cycle. That is a change every time the engine turns, and you get a new cycle on that cylinder. So every 720 degrees in the crank, you get a new cycle on each piston, and you can adjust that cycle much more quickly than you can adjust the idle control valve. The idle control valve will take 4, 5, 6, 7, 20 cycles of the piston, the 4 strokes, before you see a noticeable difference. So it's faster to do ignition and fuel. I see at 841.46. So that's 26 RPM different, but I mean that's 26 RPM is dead stable. Like if you're getting a max variance of 26 RPM, that's stable, and in a reciprocating piston engine. I can't speak for rotary engines. I can't speak for well, I guess that is dead stable for a planar Otto cycle reciprocating piston engine. Being more specific, I can't speak on rotary. I can't even speak on Otto cycle reciprocating piston rotary engines. So where the pistons are arranged in a circle. Radial engine, not rotary engine, radial engine. Starts with an R, but it's a different word. Can't speak on those either, because I don't know what would make them stable or unstable. That's an aircraft thing. So, but yeah, I see 47. I see 21. So between 20 and 50. That's 30 RPM. 30 RPM variance. And it's funny because as something heats up, I'm not sure quite what it is, as something heats up, the RPM reading and control changes. As it warms up, the RPM goes, the actual controlled RPM goes up above commanded. So now I'm centered on 830, 832, somewhere in there, as opposed to 820. And the fan is now kicked on, and we are centered on 815. So it changes as electrical load and what have you changes. And I would really love to have ELD control of the engine also. Alright, that should be idle learned, honestly. So now, we can give it a little bumpity bump. I'm going to shut the key off, and then I'm going to restart it. Okay, I wanted to make sure that fully warm, it would start right up. I was having some issues yesterday and the past few months where hot starts were a little bit sluggish. It'd take 2 or 3 cranks, and I think is what it is I had the cranking fuel turned down just a smooch too much, a little bit lower than, because I bumped it up 100. I don't know what 100 units is. I don't know if that's milliseconds or I have no idea in Neptune. It's probably milliseconds. No? Because that's a long time. Well, you're cranking though, so yeah, it's probably milliseconds. So, you know, I had it cranked down just a little bit, trying to save as much fuel as possible. But you also need, it's that balance between trying to find that point where it's the most efficient, but also the most drivable, the most usable. Because you still need to use the machine. If it's so efficient it doesn't use any fuel, then it's not running and you can't use it. Right? So, and then sometimes we get into this. I guess it's not doing it. It's moving around. Sometimes we get into this thing where the actual ignition is a quarter of a degree different from table ignition, and it just stays there. You turn the ignition control off and it goes back to table ignition dead on, and you turn it on and it goes to a quarter degree below table ignition. It doesn't actually adjust it at all. It just pulls it down a quarter of a degree and it sits there. And then what I found fixes that is cycling the key a couple of times and then restarting it, and then it starts to work. So anyway, let's give it, it's about noonish, so everybody should be awake, I hope. Let's give it a little bit of a something. Let's give it a little rev, and this is so that I can put some parameters up on the video. So fan on, we'll wait for the fan to turn off, and then I'll blip the throttle once or twice. I'm not gonna like rev the shit out of it because that's dumb. I'm sitting in my driveway. There's literally no cause for that. There's no reason. Oh, well, not doing it today because they never pulled the trashes out for me. Okay. Well, let's give them a couple of blips and see what it does. I'm not going to rev it too hard or too loud because my neighbors are nice and I don't want to piss them off. I did let them know, like, first thing when I moved in, I went around to like the 5 or 6 houses immediately near me, and I knocked on people's doors. I was like, hey, I have a car that's a project car, and I'm still in the process of tuning it. There are going to be some times when I might need to do a little bit of revving in the driveway to see some parameters and make some changes. And the exhaust is kind of loud. I'm not going to sit here and just, crank on it full blast and bounce it off the rev limiter in the driveway. I don't do that. But if I need to like vroom, vroom, kind of a little bit, it's going to be noisy. I hope you guys don't mind. And everybody was like, yeah, no, we're cool with it. As long as you're not doing it like every day in the middle of the night, early morning, like we don't care. Midday, most people are at work anyway. And the people that are home, I asked them and they were like, yeah, no, you're fine. Whether they actually mean that or not, I don't know. I guess if somebody complains, we'll find out. But we've been here a year and a half, and I've only done it the once trying to tune the idle previously, where I was just kind of, I was doing this number because I wanted to make sure that the idle would come down and rest after just a light blip. So, you know, that. But right now I'm just going to give it kind of like a 15-20% kind of hold it for half a second, let go kind of blip. And I guess we can listen and see how it sounds in the mic. I don't know how it's going to sound. We'll find out. It does come down kind of slowly. I think I would want it to come down. Yeah, there it goes. Actual ignition, for whatever reason, has frozen. It should be moving. You can see the idle is no longer stable. It's too high. And it's just kind of sitting there. It should not be doing that. So, there's something wrong with Neptune. And I don't quite know what it is. If I turn it off, okay, we come over here to idle ignition, we turn that off. It's table ignition is 16, actual is 1675. Turn it off, and it goes to 17. Because that's going to be, so table ignition is just what the ignition table is telling us. That's not intake temperature, coolant temperature, all the rest of this other stuff taken into account. It's just the table. So there's other stuff taken into account. Turn it off, goes to 17. That's a quarter of a degree below commanded ignition. I wish there was a commanded ignition also, but there isn't in Neptune. I do need a fancier ECU with a fancier program and better control systems, because I can make this engine slightly more efficient. I'm doing that. So if I take and I turn it off, cycle the key a couple times, start it back up. Now we should see the ignition still broken. Why? Is it still broken? Still broken. Okay. This is what irritates me about Neptune. This exact thing right here. You tell it to do something and it doesn't listen to you. I have no idea why it's doing that. Now it's working. I guess it takes a second after you start it to kick in for whatever reason. I don't know. Maybe it's... No, it's not only closed loop, because I have it set to above 68 degrees ECT. So even cold, it should modify the idle to maintain it at the right value. I don't know. I don't know why there's a delay there. If I were programming it, I would not program in a delay. I'd tell it to always work. No, I guess you wouldn't want to do that, because cranking, you don't want to try to adjust the ignition. So I guess you have to have a delay after crank. But for that, you should be monitoring the start pin, and whenever the start pin is no longer high, you turn on idle corrections. Because you're no longer cranking, the engine should be running at that point. I don't know. Anyway, I think that's all I've got for right now. I gotta go check the water stuff that I did, and then see if I can't turn the water back onto the house. I'm gonna end the stream here. I will cut a video over the next few days. If you guys would prefer to see a video, I'll make a video. I'll try to keep it short. I have no idea. I guess I'll need a conclusion of some kind. I don't know if I want to do that here or do it in narration, so I'll give you guys a conclusion so that we get closure in the stream, I guess. And then I might redo another conclusion for the video, or I might use this one, I don't know. So in conclusion, we can see that the modifications that we did to the ECU were successful. The wideband sensor input is still a bit noisy. We're going to need to change that in the future. We're going to have to add a capacitor. I'm going to have to sit down and do some math to figure out what exactly that capacitor value needs to be. It's going to be in the probably 100 pico to single digit nano range, farads range. So we are going to have to add a capacitor to the... Do that again. So we are going to have to add a capacitor to the wideband input to the ECU, simply because it's got a little bit of excessive noise. I am also going to have to measure the actual voltage value at the MCU. No. I am going to have to measure the actual voltage value of the OEM idle air temperature sensor at the multiplexer input, and make the values, come up with a correlation, and make the values match my additional sensor, so that I actually have a one-to-one correlation, so that I know how much the air is heating from the filter to the intake manifold, because you get some heat from the intake manifold into the temperature sensor through the sensor body. Even though it's plastic, there is going to be a little bit of conduction there. So I'm going to need to measure those values and correlate them so that I can actually use that data. For right now, it's just interesting to see the difference. They're close enough that you can see the difference in the values, so it's fine for just brain thinkings, right? And looking at the narrowband sensor input, the wideband is working correctly. The narrowband does cycle from rich to lean in the same manner that you would normally get using the narrowband to do the closed loop adjustments. So I think all in all, the mods were successful. I will continue working on ideas for what I need to do for further mods to get this machine more and more efficient. One of the next projects will be replacing the butyl rubber on the doors, because the stuff that I got previously is not all that great. It's for houses. I got some stuff now for cars, for automotive purposes. It should do a lot better. So that'll be one of the next projects. Stay tuned for a future video where I redo a thing that I've already done before. I hope you guys have a good one. As it says in the end card, like it, subscribe it, crank it, rip it. Have a nice day. Yes, I'm going to use the Lenovo mouse to move stuff in the Asus. So we'll stop recording. That's fine for there. I am going to end the stream here, clean out all of the AV equipment out of the car here, because we don't want it sitting in here for any length of time, really. Yeah, look at that. Bam. All right. And then, yeah, we're gonna end the stream, and I will see you folks in the next one. I have to go do some other things real quick, so I probably will not be. Well, I almost definitely will not be streaming tomorrow. No, actually, I might. It depends. It depends. So I have to go to another town. It's a 3-hour drive round trip. So I'm going to go get parts, put them in the customer's vehicle, drive the customer's vehicle back to the house, and I'm going to leave my vehicle at the customer's house. It's a friend of a friend. It's somebody that they're a friend, so they trust me with their vehicle driving it an hour and a half away. And it's easier for me bringing the vehicle to my tools than it is taking my tools to the vehicle. Normally with a regular customer, your standard customer, I would take the tools to them. I would figure out what all I needed and what would probably be a good idea to take with me, and I would travel to the customer's house and do the work there, so they didn't have to worry about any kind of funny business or anything. But for this person, for this customer, it's a simpler solution because it's not their primary vehicle. So it's one that they do foresee becoming their primary vehicle, which is why we're doing the work on it. They want within the next 6 months to a year to get all of kind of the current preventative maintenance done and any repairs that have been neglected completed, so that we can we can get the thing daily driver ready, because they foresee their current daily driver exceeding reasonable repairs within the next year. So that's kind of what we're doing. I'll probably stream that work because it's rear brakes, it's some fluid replacements, things like that. It's mostly preventative maintenance. The rear brakes we're replacing because they're getting low, and it's a simple enough job. So we're going to stream that. I'll have the Logitech that I can stick you guys in there with me, and then I'll probably cut it simultaneously, and we'll record it simultaneously, and we'll cut it into a video and release that. And honestly, I want the primary brunt of this channel to be kind of the mixture between streaming games on my off days, or on my non-automotive days, and then on the days that I do automotive work, streaming the automotive work and then cutting it down into videos, just kind of from the mechanic's perspective. I don't know that it's necessary. I don't know that it's a requirement. I feel like there's kind of a niche missing where people don't get to see the mechanic's perspective. Like, you see the DIY guy in his driveway, here's how you do that, which is technically what I am right now. You see that perspective, and that's generally lower quality video and audio. So my business model, the content model that I'm trying to build, is quality video and audio, like quality AV, with not necessarily money dumped into it, but I've got some quality equipment. So quality AV, and showing what it takes to work on cars, not just the cut together stuff, right? I want the streams to be, this is why it costs this much to do this, okay? But I also want it to be, it doesn't cost this much to do this. If this is what they're telling you, they're trying to take you for a ride. And that's kind of a big problem I have with the industry, is scare tactics and shops using shady business tactics to stay in business. It's, if you do your business correctly, you don't need to use these shady business tactics and scare tactics to stay in business. If you are honest and you do a good job and your work speaks for itself, that's all you need. For an automotive shop, there's a lot of people that have a lot of ideas on the way they want to do things. Some of them are less than ideal, obviously. And I aim to provide the information to people to arm themselves against those shady business tactics. Some shops, they're here to do the job correctly. I applaud those guys. I give them props. People like people on YouTube, like you got Chris Fix, Eric the Car Guy. You've got, what's that channel? I just recently discovered a channel, Driving for Answers. So driving the number 4 answers. I'm not sure where he's located. I'm gonna say Eastern Europe, because he owns a European model that in the US is called something different. It's the Toyota, what the hell is that thing called? It's a little Toyota not a hot hatch, an eco hatch. It's an eco box that we don't get here in the US. but we do get sort of a different variant of it that is called something else. So he makes quite good videos. The way he explains things is top notch. He appears. I don't know what his background is. I haven't watched the channel enough. I've seen 4 or 5 of his videos at this point. But the way he talks is he explains things almost always in the exact way that should be explained. Like, there's a way that you explain things to people. I'm not a big fan of Scotty Kilmer, because some of the things that he says, some of the ways that he explains things, I don't feel that you should be telling the people that don't know this stuff already the information in the way that he presents it. So the way that he uses the language, I feel, is a little bit lacking. That's just the way he talks. It's the way he presents information. I'm not saying it's good or bad necessarily. It's not what I feel portrays the information in a light that is most productive. We'll say it that way. That is the language that I believe portrays the thought that I am trying to portray, that explains how I see or how I perceive his content. It's not bad content. He has customers, he does the job, he gets the job done. He does do the job correctly. From what I have seen, Scotty Kilmer does the job correctly, and he's like Eric the Car Guy, and like there's a Ford channel that's been doing a bunch of eco stuff. EcoBoost engines, because the EcoBoost engines have a myriad of problems, and that's like his bread and butter, is repairing EcoBoost engines, especially repairing EcoBoost engines where some other shop did a thing and then they destroyed the engine in the process. So he spends a lot of time doing that. He does a pretty good job. I'm not a Ford fan, so I don't watch the channel regularly. Another channel that is the guy explains things from an engineer's perspective, right? He does do the work himself, and he has I don't know if it's a buddy or an employee, but there's a guy that, for things that he can't do, he pays this other guy to do it, and sometimes he's in the videos, and that's Engineering Explained. And he does a phenomenal job of the engineering explanations. He does. He actually reminds me of the guy that I want to get into a stream, one of the two guys that I want to get into a stream very, very soon, this weekend, next weekend, soon. Talking about physics, my old system engineer, Sean. The Engineering Explained guy, I don't know his name. I've heard it half a dozen times probably, and just I don't remember. I'm terrible with names. Terrible. It took me 6 months of hanging out with my best friend number 2. I've ranked them, yes. It took me 6 months of hanging out with him before I remembered his name. And his name is 2 letters. And I actually spent, I don't know, a couple years back, I spent a good, 8 months. At least once a week, I'd text him with, like, I know his name. Like, I know what the letters stand for. But I text him, like, Richard Jameson. Just random names to match the RJ of what everybody calls him. It was great. It was fantastic. Actually, wait a minute. I haven't been texting him and telling him I've been streaming. I'm going to do that real quick. Actually, tell you what I'm going to do. Well, he's probably not awake. I don't care. I'm going to call him. We're going to call him on stream. Damn, it's been a while since I texted him. And I love his phone number. I'm not going to give it to you, because, no. But we'll call him. I'll give him a little bit of heck and stream. Ain't nobody here anyway. If he even answers, he's probably not even awake. He does the shift 2 thing, where he gets up sometime around this time, sometime around noonish, generally.
Please leave your message for 52024.
We're not doing that. Well, I will call him later. We're not doing it in stream, I guess. That's fine. So, I don't know that I've actually told him about the channel yet. And told him to come join the stream. I should do that. He can just set me up, because what he'll do is he'll get up, eat breakfast, do his whatever his morning routine is, and then his job recently has been caring for his parents and his girlfriend's parents. They're both, they're getting up there. His dad has some health issues. Her dad has some health issues, right? So, and it's actually quite funny, because his family is in Arizona, her family's in Tennessee. So they travel back and forth, and they help care for their parents, and that's his and hers. It's their job. They get groceries. They clean up around the house. They fix things when they break. He's effectively a live-in nurse or live-in care. So when he's not doing whatever stuff he needs to do around the house, he just plays video games. He's on site, as it were. But he plays whatever. It used to be WoW. I don't know what he's playing now, but he used to be big into WoW. I don't think he is anymore. But, they just sit there playing video games. If someone needs them, you stand up, you go do the stuff you need to go do, and then whenever you're done with that, you go back to just being on site, right? And so that's what keeps gas in his car, that's what keeps food in his belly, roofs over his head, etc., etc. Honestly, it's not a bad deal, that whole thing, because he doesn't have to do the 9 to 5 to do what he needs to do, right? He doesn't necessarily have a whole lot of disposable income, because he's paid by room and board and keeping the his phone bill paid and the car insurance paid and stuff like that. Like, living expenses are covered, but he doesn't really get, and he doesn't ask for it either. He's not that kind of guy. He's a really good guy. He'll ask, his dad, he'll be like, hey, I want to do this. I want to build a new PC or something. And his dad's a gamer too, right? So it's funny, because his dad is so my generation is kind of the first generation that started gaming, right? As a career, as a hobby, as whatever else. We are the gamer generation, right? His dad is the generation just before that. So his dad is a grandfathered gamer, I guess you might say, where he's I guess what they'd be playing right now would be Diablo, because both of them are really, really big fans of Diablo. So they play Diablo together all the time. And his dad is I love his dad. His dad's great. He's a really good guy. He is absolutely a rage quitter. I love it. So, and it's funny, because he'll be in game, and he'll be going through a dungeon, and you can hear him in the other room. He's like, damn it, oh, you gotta be kidding me. And he'll end the game for a minute, stand up, walk around, cool off, come back, sit back down, take a deep breath, get back in the game. Okay. What did I? And he'll go through. You can hear him go through them. He'll be like, "What did I do wrong?" Okay, I need to do this. Bam, and he'll learn from the mistake that he made previously, and he'll do the level better. And sometimes he'll die 3 or 4 times, and you can hear him, "Damn it, damn it, come on, oh come on, in the other room just doing that thing, and it's just it's awesome. It's funny. He doesn't smash stuff. He doesn't break stuff. He doesn't rage quit Hulk smash. But you'll hear him in the other room getting irritated by something, especially those things where you get like a lag spike that actually kills you or something like that. That's the ones that I absolutely understand rage quitting when in like online games, especially when your hardware is up to snuff. So what the issue is it's a backbone issue or it's a server issue, something like that. Because he's got hardware. He's his job. He's an IT guy, works on base for the military. So like, he makes money, right? He makes IT contractor for the government money, which is pretty good. So he's got the hardware to back it up, which means most of the time the issue is not on his end. It's the outside world. And he's just, I love his whole family. One brother is black sheep troubleshot. Not the good kind of black sheep though. The reason the whole trope exists, black sheep. I don't know if he's gotten his stuff together yet, but he's not a nice, productive guy. We'll leave it at that. But the other brother, he's cool. My buddy's cool. His dad's cool. His mom's cool. His mom's funny. Love his mom. His mom's great. I made dinner for them one night. And I asked the parents, I was like, hey, do you guys want me to make enough for you guys? And they're like, no, we're going out to eat. That's cool. Thank you, though, So I made dinner for my buddy and his girlfriend and myself, the three of us. And it was, what was it? Alfredo. We were making Alfredo. So, homemade sauce, chicken and noodles and, some spices. So, his mom comes in while I'm cutting up the chicken. And when I cut chicken, I cut all of the fat out of it. I like my chicken lean. I want all of the fat to come from the places that I want it to come from. So in this case, Alfredo is a white cheese sauce. So I want all of the fat in the dish to come from the cheese sauce. I don't want it to be in the chicken. I also don't want, when I'm chewing chicken, for there to be gristle or anything like that. So I very precisely cut all of that stuff out, keeping as much of the actual meat as I possibly can, right? So she comes in there while I'm cutting up the chicken, and I'm cutting off the fat and setting it to the side. And she's like, no, what are you doing? She doesn't speak any English. Like, she knows 3 words in English, this woman. But I know enough Korean that I can pick up what she's saying. And she's like, no, what are you doing? Why are you doing that? Why are you cutting all the fat out? And I can't speak the language, but I can hear and understand some bits. So she's like, why are you doing that? And I'm like, because I want the fat to come from the sauce, not the chicken. And she's like, ugh. Effectively, she was like, ugh, white people. That's what it was. It was great. And then, I went in there one time. I had to give it back to her, so I went in there one time, and she was cooking. I don't even remember what she was cooking. It was probably beef. So, what is that? Bulgogi? She was probably making bulgogi. So I go in there and she's cooking. She's making it. She's got the wok and she's making the dish. I'm like, no. What are you doing? You gotta take a spatula, man. You gotta, with the spoon. You gotta do it that way. And she's like, no, just get out of here. She's fun. She's a nice lady. I like most of his family. They're cool folks. I think I've met his grandparents once too, and they're pretty cool. So yeah, stuff. I was gonna end the stream 35 minutes ago, and then I started talking about my buddy. Anyway, I'm gonna go. I need to find something to eat. I'm feeling a bit lightheaded. Should probably quit doing that, huh? I've been doing this Monster for breakfast thing, and it's really, really not good for you. I was supposed to go to the grocery store today. It's too late now. I prefer to go in the early morning when there's less people there, myself. I might go to the grocery store, like right now, actually. Close up the Civic, put everything inside, and just drive it to the grocery store. Since the Accord is down with a broken brake line, which I still have to diagnose. So, yeah, that. Anyway, ending the stream here. Anybody comes by and watches a VOD, same as always, leave a comment, let me know what you like, what you dislike, if you watch the VOD. I know there are a couple of people that do. I don't tend to. It's not my thing. But if you watch it, let me know what you think in the comments. Leave me a like, subscribe maybe, if you think I'm funny enough. I'm funnier when there's people and when there's other people involved. When I banter. I'm better at banter than I am at just direct entertainment with my face. So, yeah, we'll see you folks in the next one. Have a good day. With the wrong